Please welcome to the stage, Larry Ellison.
Hi, everybody. Let's see. Okay, so everyone is very excited about AI. It does extraordinary things. In fact, my son and I were just consulting it on a legal matter this morning because there was there was an interesting dispute between a couple of investment bankers as to certain rules about how much stock foreign corporations could own under certain circumstances, and quickly ran off and asked a multimodal AI model, and got an answer almost immediately. They're quite extraordinary. They certainly know all the laws in the UK, all the laws in the United States, the rules in the New York Stock Exchange, the SEC, all of that is trained on all of that data, and all that data is publicly available. What is less common and what people want to do but really can't do very easily right now is use their AI models, ChatGPT, Grok, Llama, Anthropic, all of them, to reason not on publicly available data where the models have been trained on the internet, all of the internet, but private data. The private trading records of an investment bank on Wall Street, or the private genomic data of a genetic engineering company that's analyzing genomes. And genomes, it's an enormous amount of data, and they'll do gene sequencing on plants. I'm going to show it in a minute because I think it's such an interesting example. We're working on a lot of plant genetics, and I'll describe a couple of the projects we have ongoing. But people don't realize how big plant genomes are. The human genome is right around 3 billion base pairs, actually a little short of 3 billion base pairs. The wheat genome is 15 billion base pairs, 15 billion base pairs. Because wheat's been around a lot longer than human beings, and wheat's been evolving over time, and when you sequence wheat, you get this massive information, and by the way, there are all these different varieties. I didn't know this a year ago, 2 years ago. There are all these different varieties of wheat grown all over the world based on variations in soil and variations in climate. And they all do things slightly differently. They do photosynthesis slightly differently. The genomes are different. And what you want to do if you want to optimize wheat, if you want to increase yield or make it drought resistant, you want to really look around at all the varieties of wheat and analyze and understand the genomes of wheat. And you've spent a lot of money to sequence all those wheat plants, and that's your proprietary information. And your business is to produce this new variety of wheat that is going to be drought resistant, higher yield, and that's your business. And you don't want to share that information with other people. How do you do that? How do you do that? Oracle ran a project inside. First thing we did, we took all of our customer data, all of our proprietary customer data, and we have a lot of customer information. We have a lot of people using Oracle in the cloud every day, where we keep track of what they're doing. We're curious about what features of Fusion applications they use more frequently, what features they tend not to use as frequently, what features require what features are not so easy to use. People tend to make mistakes in that. So we monitor all of this, and we find someone's making a bunch of mistakes using a particular feature. There's probably, the feature is not easy enough to use, and we want that insight, and we want to go ahead and fix it. But how do you get that? But back to the basic problem that has not been generally solved is, how do you take these fabulous reasoning models and allow them to reason on your private data, whether it's plant genomics or customer usage of in the cloud and what features are easy and what features are error prone. How do you take your private data, make that available to AI models while keeping that private data private? And can we make that easy to do? Because everybody wants to do that. And we've been working on this problem for some time, and we call it, and we have a new version of the Oracle database called the Oracle AI database. And we didn't name it the AI database just because AI is fashionable, as I said the other day. We did it because our new database has a lot of new features to solve this problem, to solve this exact problem, solve this one problem. How do you make all of your private data accessible to AI models for reasoning while keeping that data private without compromising data privacy in any way? And we've done that, and we call it the AI database. And by the way, it's just the latest version of the Oracle database. This is not an all-new database. This is not an AI database in the sense that Pinecone is, where it's just a vector database for AI. By the way, we added vectors to our database, but it is still the full Oracle database. It has all the Oracle security features, all the Oracle high performance features, all the recovery features, all of that. But we've added all of this AI capability to the Oracle database. So it's highly secure, highly reliable, highly scalable, very fast. But it makes your private data easily accessible by the AI models. Okay. And again, we also decided that if we're going to do that, if we're going to make the data, we actually should make it easy in the Oracle Cloud for users to pick their preferred AI model. We use a variety of AI models. I mean, again, Anthropic tends to be pretty good at code generation. So if you're doing programming, Anthropic is pretty good at that. ChatGPT is a phenomenal legal expert. I can just go into these models are somewhat different. And depending on the application, you might use one model or you might use a different model. So we decided to make all of the popular AI models available inside of our cloud. So Oracle, if you go to the OCI, you can get ChatGPT 5.0. You can get Google Gemini. You can get XAI, Grok 4 Heavy. You can get the latest versions of Llama from Meta. Because the Oracle AI database, to be an AI database, to do reasoning, Oracle doesn't do the reasoning. You need the model on top of Oracle to do the reasoning. So when you configure the Oracle AI data platform, you pick one of these models, and we then give you a private version of that model sitting on top of the Oracle database with your private data in it. And so it's all there. You just configure the model you want. I mean, basically, you click on the name of the model you want, we configure it, and put it on top of your database. And then the Oracle database will make all of the data, all of your private data that you authorize, it'll make it all available to the AI model. How does it do that? Well, it uses a technology called RAG, Retrieval Augmented Generation. It simply allows the AI model to read the database. There's a server, there's an MCP server. The AI models are designed to be able to go and read anything on the internet that's publicly available, but they also can read private data, whether it's in a file system or in a database, different kinds of databases. It can do all of that. It can go out and look at that data, read it, and actually understand it. So that's what we did. I'm going to go into a little bit of detail on how it works. What we added to the Oracle database, obviously we had RAG capability, But right now, the Oracle database can vectorize all of your data in the database. It can vectorize text, it can vectorize images, it can vectorize videos. And what AI models understand, the format of data that AI models understand are vectors. And for example, a very famous AI search is vectorize a particular movie and then show me movies that are similar in content to that movie. That's a vector search. Find me a movie where the vector is similar to the other movie or other movies somebody else watched. They use it for recommendation engines, but also for gene sequencing. There are gene sequences to do with photosynthesis. So you find a set of gene sequences that are doing photosynthesis, and you say, find me all the other genomes that I have, find me the gene sequences that are involved with photosynthesis. And we can find that part of the genome. Searching through the 15 billion base pairs, we can immediately zoom in on that part of the genome. And then you can say, show me the differences between how this plant does photosynthesis and how this other plant does photosynthesis. And you do that with something called vector search. And there's a whole bunch of vector mathematics that has vector spaces and vector distances and all of that. But that's what we do. That's what we've done to make this an AI database is allow you to vectorize all of your data, all the different types of data. Once you've done that, if you look at what we were able to do, and as I say, the first project doing this inside of Oracle, the first of our private data that we decided to make available to an AI multimodal model was our customer data. Because I'm not sure for us there's anything more valuable than our customer data. And then we started asking questions once we vectorized our customer data. And for example, you'll see what I mean by valuable. What Oracle customers, this is my second group under the second bullet, first line under the second bullet, what Oracle customers are likely to buy another Oracle product in the next 6 months? We'd like to know who they are. And we'd like to know, second line, what Oracle product are they most likely to buy? And those are the kinds of questions you can ask using a reasoning model. And it tells you. And then you can ask, but you can also have agents associated with this. It doesn't just have to be ask a one-step question. You can actually ask this, okay, well, let's send email to all of those prospective buyers, and let's show them the 3 best Oracle references for you. In other words, in your industry, in your country, that are bought the same product and used it successfully. So as you look at this, I mean, you would build, if you were a company building CRM software, or sometimes called CX software, customer engagement software, the ability to enable your customers to ask these kinds of questions, to build an application, CX application suite, where you could do this kind of AI marketing, if you will, AI reasoning on top of the customer data, and qualify leads and then pursue leads with agents. You qualify leads through the reasoning process, and then through the agent process, you would go ahead and pursue those leads. That's how you'd go about building the next generation of CX applications, and that's what we're doing. And we do all of that while maintaining the strict privacy of your customer data or your genomic data or whatever. And medical genomic data is very, very sensitive. So you have to keep it private. So the Oracle database security model, which we've worked on for decades, is what we rely on to keep this private, because the vectors are inside the Oracle database. And we use a security model, again, that we've been working on for a long period of time to make this, keep your data private while making it accessible to AI models. Next slide. Ooh, I'll press my clicker button. Okay, there. Great. Okay, so as we're building the next generation of CX products, we are the owner of Java. The Supreme Court might disagree with that, and Google probably would too, because they won the case. But we bought Sun, who developed Java. We are the primary maintainer of Java, and it is the world's most popular programming language to this day. However, in the age of AI, you can use something like Anthropic or ChatGPT or Grok to write code. And you can just declare your intent. In other words, just say what you want the program to do, and the AI will generate the step-by-step process to do it. So it won't be conventional coding. It's called vibe coding, an interesting term, which is just, I guess, field vibe, very, very modern term for coding. But it's really just, what do you want the program to do? You just tell me what you want the program to do, and don't worry, I'll generate it. Now, we have been doing this for a while, doing code generation for a while, and there's a big debate inside of Oracle, and there are people on both sides of the debate, and I'll tell you what side I'm on, which is programming in English. In other words, declaring what you want the program to do in English. English is a notoriously imprecise way to communicate. It's not like mathematics. There's a lot of ambiguity in English. To make English perfectly clear, perfectly precise, is very difficult. So we think you could have an alternative declarative programming language which was designed to declare intent of what a program should do. You could create that language with great precision, and then with great precision you could generate the code. Now, the jury's out. People are programming and declaring intent in English and generating code, and people are declaring intent in specialized languages to declare intent, designed to be precise and designed specifically for code generation. Having done both, I'm a great believer in a more specialized language. I think once you learn the specialized language, you're much more productive in generating code. And our experience is, I mean, these are huge improvements in productivity. 10x productivity if you generate the code rather than writing the code. One of the reasons we felt we could take on something like Cerner, and we knew we were going to have to rewrite all the Cerner code. We have to rewrite it all. And it took decades for Cerner to write that code. And we thought we could rewrite it all in a few years because we weren't going to rewrite it. We were going to generate it using AI. And that's what we've done. And built very complicated and interesting agents, using AI. And in fact, in the future, what are computer programs? Computer programs are a collection of agents connected by workflow. That's what they'll be. Okay, this is a big leap from code generation and making your private data accessible to AI models. This is a greenhouse that we have developed. It's version 3 of a greenhouse that we're developing. Actually, it's Danny Hillis's team. Oracle made an investment in what's called applied inventions. Danny Hillis, by the way, invented thinking machines when he was an undergraduate at MIT. Actually, Danny and I used to be competitors. I was working on a computer out of Caltech, with a Caltech team doing something called N-Cube, which was massively parallel computing. It was parallel computing. It was, if you will, the precursor to NVIDIA and vector processing in computing. It was doing a lot of calculations in parallel, which obviously is very important now. Unfortunately, as Danny and I discussed, because we both failed, N-Cube failed and thinking machines failed, we both lost a lot of money and a lot of time on this. We learned a lot. But we were about, I was going to say 20 years too early, but it was more than that. I don't even want to talk about it. I'm going to do the calculations. But anyway, Danny is now, we bought his company, and one of the things that we're working on is robot, and he's really responsible for, amongst other things, robotics inside of Oracle, because robotics is a very special case of AI. The leading AI model for robotics is very easy to figure out. It's owned by Elon Musk, but it's not Grok. It's the AI model he built at Tesla, and the first popular common robots in the world. Other than, I mean, yeah, there are robots. There are general purpose robots. Yes, there are robots that assemble PCs and laptops and desktop PCs and a lot of electronics and iPhones and all of that. There are tons of special purpose robots. But the first, what I would call kind of general purpose robot, is the self-driving robot that Tesla has created. And then Elon is working on his second group of robots, which are humanoid robots. So he's going from four-wheel robots to two-legged, two-armed robots, general purpose robots, using full AI model, real-time AI models. And we're doing, we're not creating the AI models from scratch. We're using those models to automate a variety of things, and this is a greenhouse, by the way, that has no people in it. That yellow thing over there, they're very large. The reason there are no people in it, there are a few reasons. One is the atmosphere inside of this greenhouse. By the way, there's no structure. This building is held up by air pressure. So there's positive air pressure inside of the building, and that holds up the roof, which is ETFE, which is a kind of plastic that lets through, it's the most transparent material in the world, lets through more light than any other material, more light than glass or other forms of plastic. And if you talk to Danny and said, well, what do greenhouses do? Well, basically they can convert sunlight and CO2 into food. And we don't let people in here because people can contaminate the plants, and people aren't going to like all the CO2 and all the humidity we have in here. And the robots will move the plants from the growing area into the harvesting area. And AI decides when you harvest the plants. You know, there are cameras. AI decides we can grow different crops in here. It's the only greenhouse you can have lots of different crops inside the same greenhouse, because it's completely computerized, and the nutrition, if you're growing strawberries, is very different than the nutrition when you're growing lettuce. The heating requirements, we heat the plants from the bottom. We don't heat the whole building. Anyway, I'm not going to give you all the details. But each area is carefully climate controlled, atmospherically controlled. The hydroponic nutrition is all computer controlled. And it's designed to produce food at a much higher quality and a much lower cost than currently other forms of indoor growing. By the way, when you grow indoors, you use 90% less water, which is truly incredible. By the way, this is also a habitat for Mars. So if you think about an interesting use for a greenhouse, I don't think it's a huge market. I don't think our Martian market's going to be gigantic. It's not in our numbers, by the way. None of the Martian consumption of our technology is in any of our numbers. That's all upside. So what does the greenhouse do? The greenhouse grows food, and if you're going to have people living on Mars, you need to grow food. But it also converts CO2 into oxygen, doesn't it? So if you're going to have people living on Mars, they're going to have to breathe, and you can either ship the oxygen from Earth to Mars, or you can create the oxygen from CO2 on Mars. And the people can create the CO2 that the plants will consume. So this is a kind of a combination. Its intent, by the way, our first market, we really have focused on Earth. But we just noticed that this thing would be a perfect habitat for Mars, or other places that you want to go. As I say, it's not in our business plan. This is what the whole building looks like from the outside. The green areas are the harvesting areas. The robots will move the plants into the harvesting and packaging areas. And again, there are no people in the growing areas at all. It's kind of interesting. As long as we're talking about plants, I want to give you an example of the kind of things we're doing with our database to make it work better with AI. And in addition to being able to vectorize all of the data, which makes the data easy for AI to consume, we've also created special data types, let me get my verb tense correct, but are in the process of creating special data types for DNA. And say the DNA searches, a DNA search of, by the way, that is wrong and it's my fault. It says the wheat genome is 15 million base pairs. It's 15 billion base pairs. Human being, 3 billion base pairs. And it's got all of the historic genes, all the genes that became obsolete during the hundreds of millions of years of evolution of wheat on the planet Earth. It's just a grass. Wheat on the planet Earth is recorded in that genome. That's why it's so large. We don't delete. When genes suddenly stop being used, they don't get deleted. So there's a whole history of how the wheat evolved. That's very interesting that you capture when you gene sequence wheat or you gene sequence plants, or animals for that matter, you capture their evolutionary history. And the things we're doing, another team is doing, not Danny's team, is looking at wheat photosynthesis. And if you can improve wheat photosynthesis, and they have improved wheat photosynthesis using AI. They've changed the genome. They've used CRISPR-Cas9, a gene editing technology, to improve photosynthesis. When you improve photosynthesis, you convert more CO2 and more sunlight into food. So the yield per acre of this wheat we created, they created. I didn't have much to do with it. Actually has 20% more yield per acre. So we're producing more food in the same space. Another thing that we're looking at, and that's already working today. So the increased yield through using AI to figure out how to improve photosynthesis. Then once we figure out how to do it, you use CRISPR-Cas9 to go ahead and do it and actually do the gene edits. The thing we're looking at right now is not just converting CO2 into food, but also converting CO2 into calcium carbonate. I'm sure all of you will be fascinated by the fact that the coral reefs are made up of calcium carbonate. The plants that live in coral reefs actually secrete calcium carbonate, their own skeleton. Well, we have skeletons too, right? They also have a lot of calcium in them. We are now engineering a version of wheat that will convert CO2 out of the atmosphere into calcium carbonate, an inert version of CO2. Therefore, you can have varieties of wheat that take vast amounts of CO2 out of the atmosphere and deposit it in the ground as little tiny microscopic pieces of sand, calcium carbonate sand. And you can manage the level of CO2 in the atmosphere pretty much to whatever you want it to be at no cost. At no cost. And the world right now is working on this problem of figuring out what to do with CO2 in the atmosphere. And they have all these interesting ideas, which including getting rid of all fossil fuels, which is very difficult. But there are other ways to tackle the problem that might be much easier and much more cost effective. And then, by the way, if you look at the markets, the markets, you can actually figure out, if you're a farmer, you can use satellite imagery, AI and satellite imagery, to look at your wheat fields and figure out exactly how much CO2 you're taking out of the atmosphere, and then you can get carbon credits. You can trade it for carbon credits. Okay, and kind of an interesting approach to, initially, a much simpler approach to managing CO2 in the atmosphere than what we're currently doing. Another one, another interesting example that we're working on, again with plant genomics, using DNA data types, using vector search, for using all these AI capabilities. It's right now we fertilize almost all the plants that we fertilize in North America and Europe throughout. We fertilize them with nitrogen fertilizer, huge amounts of nitrogen fertilizer. Because even though there's tons of nitrogen in the atmosphere, nitrogen is the most common element in our atmosphere. We breathe it in. We don't use it, but we breathe it in every time we take a breath. But some plants, soybeans, for example, actually get their nitrogen directly from the atmosphere. Well, we can engineer corn or wheat or other plants to get their nitrogen from the atmosphere, so that we don't need fertilizer. And fertilizer does incredible environmental damage. During rains, it runs off into rivers. A bunch of nitrogen runs into the rivers and into lakes. You get these big plankton, these big blooms of plants in the lake and in the rivers. And plus, a lot of farms can't afford to buy fertilizer. Therefore, their yields are half what the farm yield should be. Well, we can fix that. We can fix that by having versions of corn, version of these grains that fix the nitrogen from the atmosphere. So that's my presentation on what we're doing with the Oracle database. The primary thing, make it easy for people to use AI models on top of their private data while keeping it private. And then we have all of these advanced technologies that we're adding right now, so that if you are in the business of genomics, and by the way, that's every pathology department, that's all of medicine is in the business of genomics. All of agriculture is in the business of genomics, these two enormous businesses. Your database have to fully understand DNA and have operators that can operate on these enormous data types, these enormous genomic data types. That's what we've been doing. That's what we're currently doing. I think, again, fully ignoring Mars, there's enormous upside to our database business over the next 5 years. We think it's going to be one of our fastest growing businesses, and we don't think, and I'm happy to talk about this later when we in Q&A. We don't think we have a lot of competitors left in the database business. It's fascinating. Our primary competitors in database, let's say they're maybe Databricks, you could say is new, or it's kind of the newest one, Snowflake. They don't even do transactions. They're query-only systems. There aren't a lot of new database technologies being invested in. We're kind of the only game in town. We think that gives us an enormous opportunity to increase our franchise in the database business over the next 5 years, and the dawn of the AI era, if we can merge our database technology with the latest AI technology. Thank you very much.